In this video, we're going to talk about how to evaluate trig functions at angles that don't appear in the standard picture of the unit circle. So you'll notice that all of the angles that we have to evaluate at here, they are not labeled over here. But that doesn't mean that we can't evaluate these trig functions, because these angles still correspond to points that are labeled on this unit circle. We just have to find out where those points are. Okay, so let's see how to do that. Now our first problem asks us to evaluate cosine at 9 pi over 4. Now I don't see 9 pi over 4 labeled anywhere in this picture, but maybe I can still find what position it corresponds to. How do we do that? Well, all I have to do is find out how much 1 pi over 4 is. That gets me this far. So we're going to be looking at angles that are this much, 45-degree angles. So they take me this far on the unit circle, from this point to this point. And then I'll just count 9 of those. So notice that when we count these, we're going to skip over these blue angles because pi over 4 goes further than that. So when I count, I'm going to go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. So that puts me right here. Now also notice that when I'm doing this and I count 2 pi over 4, notice that that simplifies to pi over 2. So I know I'm in the right place if I just do a little bit of simplification. 3 pi over 4, 4 pi over 4 simplifies to pi, 5 pi over 4, 6 pi over 4 simplifies to this, 7 pi over 4, 8 pi over 4 simplifies to 2 pi, and 9 pi over 4, like we said, puts me here. Cosine is the x-coordinate, and so the value is root 2 over 2. So we get to these just by counting around the unit circle. Now let's look at this one, 35 pi over 4. Now that's a lot of counting, right? Now I could do it the same way. Just start counting around the circle 35 times, right, until I get there. But let's be smarter about it, all right? So notice that 8 pi over 4 simplifies to 2 pi, right? So 8 pi over 4 gets us all the way around the circle. So every 8 pi over 4 that divides into this will get us back to the starting point. So if we just divide the numerator by 8 and look at the remainder is how much further we have to go from the starting point. So how many times does 8 go into 35? Well, 8 times 4 is 32. And what's the remainder? The remainder is 3. So I know that after going around the circle some whole number of times, there'll be 3 pi over 4 radians remaining. 1, 2, 3. That's going to correspond to this angle right here. Tangent is the y-coordinate divided by the x-coordinate, and that we see is equal to -1. Let's go to this next one. Here we have a negative angle. Notice none of the angles that are labeled here are negative, but we can still find this. -3 pi over 4. Well, that's -1 pi over 4, -2 pi over 4, -3 pi over 4. That puts us right here. What's sine? Sine is the y-coordinate, so this is going to be negative root 2 over 2. Let's do the same thing for this one. Well, this is a negative angle. Now that's a lot of counting. I could count pi over 6's. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, etc. I'd have to count all the way up to 100. That's going to take a while. But let's think about this the same way we thought about this one. All I have to do is figure out what 2 pi is. 2 pi is 12 pi over 6. All I have to do is divide 100 by 12 and find the remainder. That's how much further I have to go past the starting point. Well, 12 times 8 is 96. What is the remainder? 4. I need 4 more to get to 100. So I'm just going to go 4 pi over 6 more than here. So 1, 2, 3, 4. That's negative 4 pi over 6. What is secant? It's 1 over the x-coordinate. So it's 1 over negative 1/2, and of course that is negative 2. So this is how we can evaluate trig functions on angles which don't appear in the standard picture.